All right, so we are going to talk about dynamic receive focusing real quickly. And dynamic receive focusing utilizes the idea that a the a reflection is comes off of an echo will be, so here's a little echo coming off of a reflector, and the distance to the transducer is shortest when it's coming directly back. It is slightly longer to parts of the transducer, there we go, which are, whoops, at angles to it. So it takes slightly longer to get to that part of the transducer than it does to the center, and of course it takes even longer to get way over here to this part. And so dynamic receive focusing is able to take these signals that come back from this, which are electrical pulses, and blend them together in the receiver to form one pulse, as if it came from this reflecting structure all at the same time back to the transducer. With dynamic frequency tuning, what happens is a pulse is sent out from the transducer, and we know from our previous studies that there is a certain bandwidth associated with that pulse that is centered around a center frequency, which is what we would say we're scanning at typically, but that it has frequencies within it that are higher frequencies, and also frequencies that are lower frequencies. Okay, so even though we say we're scanning at, say, 5 megahertz, some of these frequencies are higher, up to maybe 8, and some are lower, down to maybe 3 or 2, whatever. But it makes use of this fact, and so anything in the near field is scanned, automatically processed, utilizing these high frequencies in the broadband, so that all this area is all high frequency pulse. Then the mid portion is all going to be from the center frequency, and the deeper portions of the image are going to be scanned using the low frequency portions of the bandwidth. And this is all done automatically, and it makes no difference the location of the reflectors. It has to do with the depth of the penetration. So whether we're using high, medium, or low frequency within our broadband will just depend on the depth that we're imaging at. And again, this is done automatically, and we don't have to worry about it. This is dynamic frequency tuning.